Alright, welcome back. Mr. Bell's Wildcat Math class. This is our last video. Just for now. We'll make some more later. But so we're finishing up the Liberal Arts Semester 1 exam review. We're on number 56. Wrap it up. Alright, so it says, what is the vertex? What is the vertex of the graph? The parent function of this is y equals x squared. Okay? This graph, the parent function, this one here, just looks like this. Okay? It's a parabola. The vertex is at the origin 0, 0. Okay? So what happens when I add a number at the very end? Add or subtract a number at the very end. What happens to the graph?
It goes down.
Well, if you subtract a number, it's going to go down, right? So let's make it go down 4, right? So the whole graph shifts down 4. What happens when I add a number with the x?
It goes left 6.
It goes to left 6, right? So this graph is going to go left 6, that'd be negative 6, and then it's going to go down 4. That'd be negative 4. So the new vertex would be right there. The graph would just be like that. Does that make sense? So what's a new vertex? Negative 6, comma, negative 4. Does that make sense?
Could you do it without doing that?
Could you do it without doing the graph? Yeah, it's the opposite of this, because the x is lying to you, and then this number. So negative 6, negative 4. Alright? Number 57. Vertex for y equals x minus 1 squared plus 5. What's the vertex?
So you can go down, go 5. Go down 1, go left 5.
Nope, you got it. You switched it.
Up one.
It's the opposite of this,
So,
because x is lying to you,
okay.
and then it is this number. There's the new vertex. You do it right 1 and up 5. Alright, 58, let's see. Which representations model the repair situation in which road pumps water out of the pool at a rate of 200 gallons per hour? Alright, so this first one, on the left-hand side we have water in gallons, so that's the amount of water in the pool. And on the bottom is time. So we're starting out at 0. Right when he starts out, there's 1,800 gallons in the pool. Now this is 18 over here, so it looks like we've got about 9 hours here. So after 9 hours, that 1,800 gallons comes down to 0, which is at a rate of 200 gallons per hour. If he's pumping 1,800 gallons out in 9 hours, that's 200 gallons per hour. So, is there another one like that? Which representation? Let's see, this one is, how much is he pumping out per hour here?
200.
He's pumping out 200. No, because look what happened here between hours 1 and 2. How much did he pump out in that hour?
300.
He pumped out 300, so he's not pumping out 200 gallons per hour there. That hour he actually pumped out 300. So it wouldn't be that one. What about this one here? Oh, that's pretty good. Every hour, right? 1, 2, 3, 4, 5, 6. It's decreasing by 200 each time, right?
Yeah.
Alright, so this one works. So this one works and this one works. What about this one over here? Looks like he's starting with more than 1,800 a little bit more, but it's taking him almost 18 hours to pump it out.
So it must be like a line here with the 500.
Yeah, this is not working either. So I would say these two are pretty good representations of 200 gallons per hour. All right. 59, what's going on here? Given the graph of each quadratic below, y equals f of x. Give the solution to f of x equals 0, and give the y-intercept. Okay, so the graph given is actually the graph of this equation. The equation right underneath it. And they want the solution and the y-intercept. So where do we find the solution on the graph? If you're just looking at the graph, where's the solution? Anybody know?
Where it crosses, right?
Where it crosses the
X-intercept.
x-axis, right? Where it crosses the x-axis. So what number is this here? And what number is this here?
5
-1.
and -1.
So the solution is x equals 5 and -1. Good. And what's the y-intercept? Where does it cross the y-axis?
Right here.
Right here. What number is that?
4.
I'll tell you what, sometimes the graph's a little hard to see. It's the constant in the equation. It's the number without a variable. So look at the equation. The very last number does not have a negative 5. It's actually crossing the y-axis at -5. Okay? So the y-intercept would be -5. So the x is 0, -5. That's where it's crossing the y-axis at 0, -5. Okay? Remember, the y-intercept is the constant. It's the number at the end. Okay? All right, and the last question. So it's that. Oh, there's another one, 60? Oh, good, good. I was going to say, if there's something else you want to see on my channel, leave a comment at the bottom, and I'll try to get that on there for you. Okay. So what's the solution to this graph? Where's it crossing
0 and
the
5.
x-axis? X equals 0 and 5. Good. And where's it crossing the y-axis? What's the constant?
-5. 5.
The y-axis.
0.
0. There is no constant. There's no number without a variable. You see that? There's no number with every term in here has a variable, so there is no constant. So it's actually crossing at 0, 0. Right there. Okay. All right, number 60. Choose solution that's closest to the system of inequalities. Okay, so what we need to do is get the y by itself on the left. So right now this equation is good. See how the y is by itself on the left? Yeah. So we need to do the same thing with that top equation. So let's do it here. So we've got what, 2x minus y is less than or equal to 2. I want to get the y by itself on the left. Okay. So I'm going to move this 2x over. So I'll subtract 2x to both sides. So I got negative y is less than or equal to, I can't combine these, negative 2x plus 2. And then I'll divide everything by -1. So I've got y, this becomes 2x minus 2. What happens to the sign?
Flips,
Why?
because you divided by negative.
Because I divided by a -2. So that, back to this, that first equation, we're going to change that to y is greater than or equal to 2x minus 2. So those are the two equations. Those are the two equations we're using now. Okay. So if we take just a second, look at the lines, just the lines themselves. They're all, aren't the lines all the same? They're all in the same place?
Yeah, you put different.
The lines are all the same, just the shading's different, right? Yeah? Look at our signs. Now that we've got the Y's by themselves on the left, look at our signs. What are they? They're both the same sign, right? They're both greater than. Right? Greater than or equal, greater than or equal. So when you think of greater than, do you think of above or below?
Above.
Above. So all the shading should be above both lines. Okay? So we're looking at this line. Is the shading above it or below it?
Above.
Above it. If we look at this line, it's above it, right?
Yeah.
So this is probably the answer, but let's just confirm. Look at this line here. The shading is below it, isn't it?
Yeah.
Yeah, so it won't be that one. Look at C. The shading's below the line, isn't it? Not that one. And heck,
Below.
it's both below for both of them there, right? So this is the only one that has a shading above both the lines, and that's what we have, greater than or equal to, greater than or equal to. So is our answer, good. Woo! Woo! All right, it was fun, guys. We'll see you next time.
Okay,